Assalamualaikum warahmatullahi wabarakatuh. Today we are going to present our group project which is steam sterilization system. We are from group 12. Steam sterilization system used to sterilize medical equipment. It used saturated steam to kill microbe via protein denaturation. So this system work in aggressive environment which is high temperature and pressure. So in this system, we analyze the ceramic heaters, polymer tube and valve, and composite enclosure panels. For ceramic heater analysis, the material used is silicon carbide. It have low coefficient thermal expansion that can offer excellent thermal shock resistance. For the property, it have very efficient heat transfer and energy saving. Second, it have high melting point that due to covalent bond that have diamond shape arrangement. Moreover, it have high compressive strength which is about 300 megapascal that can suitable for environment like high pressure. And lastly, it create a protective layer for oxidation resistance. For the processing route, first is powder preparation. High purity oxide or nitride powders are mild to a fine and uniform size. Secondly is forming. The powder is shaped using dry pressing or isostatic pressing to form the heater element green body. Thirdly is sintering. The shaped body is fired at high temperature to densify the part by solid state diffusion to create a strong component. And lastly, machining. Final dimensions are achieved via diamond grinding due to material extreme hardness. Ceramic heaters fails due to thermal shock. So rapid cooling causes the surface to contract faster than the core. Then it creates surface tensile stress. So why this happen? Because ceramic cannot stretch due to there is no slip system. Then it can cause to surface flaking. Secondly is hydrothermal corrosion. So high pressure steam attack the grain boundaries and cause the static fatigue. So we propose three ceramic solutions. First is advanced proposing. So we apply pressure during sintering by hot isostatic pressure. This can minimize porosity. Secondly is we make design modification which is using fillet instead of sharp corner. This is because it can reduce stress concentration factor. And lastly, make material substitution, which is replacing alumina with silicon nitride. This is because silicon nitride have lower coefficient thermal expansion instead of alumina. It can reduce thermal strain and it have higher fracture toughness that can resist crack propagation. For the polymer, polyphenol sulfate tubes and valves used in autoclave. First, in material properties, PPSU is amorphous thermoplastic with stable structure because it contains benzene group that link with ether and sulfate group. Second, PPSU has high glass transition temperature which is about 220 degrees Celsius. And third, PPSU have infinite hydrolytic stability because it can resist the hydrolysis process. For the processing route, first is drying process using desiccant dehumidifying dryer. This is because we want to ensure that there is no moisture inside the polymer. Then is melting process using ceramic heating band. Thirdly, extrusion process. So PPSU will enter the dies shape to produce the longer tube. Then vacuum sizing tank process, which we apply negative pressure inside inner diameter. And lastly is slow cooling process. Next is polymer failure mode. First is thermal aging, which caused by long-term exposure to heat and oxygen. The mechanism is chain scission, where the polymer backbone breaks, reducing molecular weight. As a result, material lost ductility, becoming brittle and prone to snapping. Secondly is environmental stress cracking. This is caused by chemical exposure and mechanical stress. The cleaning agent lower the energy required to disentangle polymer chain. As a result, microvoid forms and propagate into deep cracks rapidly. For design improvement, first we add annealing step in the processing route. PPSU is heated to 200 degrees Celsius for several hours as it can relax polymer chains to remove residual stress. Secondly, make surface plasma treatment using atmospheric plasma treatment. This can create a cross-linked skin layer on the tubing surface and act as a barrier. Thirdly, using ceramic reinforced composite. We can switch valve bodies to carbon fiber reinforced PEEK as it can increase tensile modulus and creep resistance. Next, we move to the composite enclosure analysis. It is made from unsaturated polyester resin. So this material it consists of double carbon bond that will react with styrene to produce a rigid and cross-linked 3D network. And it also made from reinforcement which is glass fiber. Next is processing road. It is made from the spray up, which is by open molding or hand rolling. First of all, chopped glass fiber and resin are sprayed together onto an open mold. Then, rollers are used to press the material and remove trapped air. And lastly, peroxide catalyst start the curing process and hardens the panel. For the composite failure mode, first is chemical hydrolysis. So water at 134 Celsius will attack the ester linkage and it causing the bond split into carboxylic acid and alcohol. So as the result, polymer network becomes soft and loss of structural integrity. Second is osmotic blistering. So water enter voids in the material and dissolve soluble residue inside. Then it causes high internal pressure that force layer apart. Thirdly is viscoelastic creep. So moisture act as plasticizer that lower the glass transition temperature and the matrix will turn into rubbery. For design improvement, first is manufacturing change. We will switch to vacuum infusion process that cure under vacuum, which approximately 1 bar. Then it can eliminate void content that cause of blistering. Second is reinforcement upgrade. We will switch to woven carbon fiber that have higher specific stiffness. Thirdly is metric substitution. We will switch to high temperature epoxy instead of polyester. This is because it contains of ether bond instead of ester bond that chemically immune to hydrolysis. And lastly is surface protection. We will apply vinyl ester gel coat as the innermost layer to act as high chemical resistant barrier. As conclusion, the failure that occur in steam sterilization system are due to aggressive thermodynamic environment such as high pressure and high temperature. So we need comprehensive solution for each material so that we can extend the service life and reduce operational maintenance. That is all from us. Thank you for your time and consideration.